Debugging. Xcode's debugger called LLDB is a fundamental tool that will help you find these bugs and fix them. This chapter gives you an overview of Xcode's debugger and its basic functions. A buggy project. First of all, you will create an iOS single-view application named Buggy. As you write this application's code, keep in mind that it is a buggy project. You may be asked to type code you know is incorrect. Implement an action method named buttonTapped. In main.storyboard, create a button titled Tap Me and add the necessary constraints. Set the font for this button and then add the constraints. Make the connection in Interface Builder. Control drag from this button to the view controller and select Button Tapped from the pop-up menu. Build and run the application. Make sure the called button tapped message is printed to the console when you tap the button. Debugging basics. The simplest debugging uses the console. Let's look at some examples of how the console can support your request for bug-free code, interpreting console messages. Time to make some mayhem to the buggy project. Suppose that after considering the UI for a while, you decide that a switch would be better control than a button. Open view-controller.swift and make the following changes to the button tap method. You renamed the action to reflect the change of control, and you changed the type of sender to UI switch. Unfortunately, you forgot to update the interface in main.storyboard. Build and run the application, then tap on the button. The application will crash and you will see a message logged to the console. The really useful information is at the very top. Let's start with the very first line. There is a timestamp, the name of the application, and the statement unrecognized selector sent to an instance. The statement means that the application tried to call a method on an instance that did not have it. This instance is a buggy view controller. Swift namespaces include the name of the model, which in this case is the application's name. This line from the console tells you that the selector button tapped was sent to an instance of buggy view controller, but it was not recognized. The next line of the message adds the information that the app was terminated due to an uncalled exception and specifies the type of the exception as NS invalid argument exception. The bulk of the console message is the stack trace, a list of the functions or methods that were called up to the point of the application crash. None of the calls in the stack trace had a chance to return, and they are listed with the most recent call on top. Scan the stack trace from the bottom up. You can get a sense that the application tries to send the corresponding action, but the selector for the action is not found, resulting in an exception being raised. As you gain more experience, you will start associating error messages with types of problems, and you will become better at debugging code. Fixing the first bug. Reviewing viewController.swift You discover that you changed your action method from button tapped to switch toggled, which is why the selector button tapped is not being recognized. To fix the bug, you have two choices. You could update the action connected to the button on main.storyboard to match your new action method, or you could revert the name change on the switch toggled method. You decide that you do not want a switch after all, so open viewcontroller.swift and change your method back to its earlier implementation. Remember what we told you, make the chances exactly as shown, even if you see a problem. Build and run the application. It works fine, or does it? Actually, there is a problem which you will resolve in the next section. Caveman debugging. The method of debugging programs by strategically placing logs is called caveman debugging. Swift has 4 literal expressions that can assist you in logging information to the console. They are var, line, column, and function. To illustrate the use of these literal expressions, update your call to print in the button typed method in viewcontroller.swift. Build and run the application. As you tap the button, you will see the messages logged to the console. The Xcode Debugger (LLDB). To continue your debugging experiment, you are going to add another bug to your application. Add the bug method to viewcontroller.swift and call it in button tapped. Build and run the application to confirm that a tap on the button results in the application crashing with an uncalled NSRange expression. Frequently, this is the case when debugging. Problems are not obvious, and you need to do some investigative work, setting breakpoints. Assume that you do not know the direct cause of the crash. You just know it happens after you tap the application's button. A reasonable way to proceed would be to stop the application after the button is tapped and step through the code until you get a clue as to the problem. Open viewcontroller.swift. To stop an application at a specified location in the code, you set a breakpoint. The simplest way to set a breakpoint is to click on the gutter to the left of the editor pane next to the line where you want execution to stop. Try it. Click to the left of the code line. A blue marker indicating a new breakpoint will appear. After a breakpoint is set, you can toggle it by clicking on the blue marker directly. If you click on the marker once, it will become disabled, indicated by a pale shade of blue. Another click re-enables the breakpoint. You can also enable, disable, delete, or edit a breakpoint by right-clicking on the marker. Selecting Review in Breakpoint Navigator opens the Breakpoint Navigator in Xcode's left pane with a list of the breakpoints in your application. You can also open the Breakpoint Navigator by clicking its icon in the Navigator selector. Stepping through code. Make sure your breakpoint on the button type method is set and active after all the clicking you did in the previous section. Run the application and tap on the button. Your application hits the breakpoint and stops executing, and Xcode takes you to the line of code that would be executed next, which is highlighted in green. It also opens some new information areas. This screenshot shows the names of different areas. Now it's time to start advancing through the code. You can do this using the buttons on the debug bar. Continue program execution resumes normal execution of the program. Step over executes a single line of code without entering any function or method call. Step in 2 executes the next line of code, including entering a function or method call. Step out continues execution until the current function or method is exited. Click the Step Over button until you highlight the bad method line. Do not execute this line. Note that you do not step into the print method because it is an Apple written method. You know there will be no problems here. With bad method highlighted, click the button to step into the bad method and continue stepping through the code until the application crashes. It will take you quite a few clicks, and it will look like you are going through the same lines of code over and over. In fact, you are, as the code loops over the ranges. As you step through the code, you can pause to mouse over I and array.remove object to see their values update. Once the application crashes, you have confirmation that the crash occurs within the bad method. With this knowledge, you can now delete or disable the breakpoint at the function button tapped line. To delete a breakpoint, Control-click it and select Delete Breakpoint. You can also delete a breakpoint by dragging the blue marker out of the gutter. It seems the application is safely completing the for loop, but you need to be sure. Find and control-click your breakpoint marker again, selecting Edit Breakpoint as before. In the editor pop-up, click Add to the right of the sound action to add a new action. From the pop-up, select Log Message. In the text field, enter parse number H. Finally, make sure the Log Message to Console Read button is selected. Run the application again and tap the button. The application will crash as before. But this time, if you watch the console, you will see that the breakpoint was encountered 4 times. This confirms that your code is completing the loop safely. Now add a new breakpoint on the line array insert. Edit the breakpoint to log the parse number and continue automatically as before. Run the application and tap the button. When it crashes, scroll up in the console and you will see that the first breakpoint was encountered 3 times and the second was 4. That is 1 time too many, and you have your smoking gun. It also explains the NS range expression logged on the console as the application crashes. Carefully read the crash log on the console again and make as much sense of it as possible. Before fixing the problem, take the time to explore a couple more debugging strategies. Exception breakpoint could tell which line of code is causing an uncaught exception resulting in a crash. Open the breakpoint navigator and click on the Add icon on the lower left corner of the window. From the contextual menu, select Expression Breakpoint. A new expression breakpoint is created and a pop-up appears. Make sure it catches all expressions on throw. Run the application and tap the button once again. The application automatically stops and Xcode takes you to the line that directly causes the expression to be raised. Note, however, that there is no console log for exception. That is because the application has not crashed yet. To see the crash and read the cause, click on the Continue Program Exception button on the debug bar until you see the crash. This strategy is the one to begin with as you tackle a new bug. In fact, many programmers always keep an exception breakpoint active while developing. Why did we make you wait so long to use it? Because if you had started with an exception breakpoint, you would not have needed to learn about the other debugging strategies, and they have their uses too. Feel free to remove this breakpoint if you would like. You will not need it again. You are going to try one final technique, the symbolic breakpoint. These are breakpoints specified not by line number, but by the name of a function or method referred to as a symbol. Symbolic breakpoints are triggered when the symbol is called, whether the symbol is in your code or in a framework for which you have no code. Add a new symbolic breakpoint in the Breakpoint Navigator by clicking the Add button on the lower left corner and from the contextual menu, selecting Symbolic Breakpoint. In the pop-up, specify bad method as the symbol. This means that every time bad method is called, the application will stop. Run the application to test the breakpoint. The application should stop at bad method after you tap the Tap Me button. Symbolic breakpoints are most useful to stop a method that you did not write, such as a method in one of Apple's framework. For example, you might want to know whether the method loadView is triggered for any view controller within the application. Finally, fix the bug. Build and run the application again, and tap the button to test it. The LLDB console. A great feature of Xcode LLDB debugger is that it has a command line interface. The console area is not only used to read messages, but also can be used to type LLDB commands. The debugger command line interface is active whenever you see the blue LLDB prompt on the console. Make sure your symbolic breakpoint on bad method is still active. Run the application and tap the button to break at that point. Look at the console and you will see the LLDB prompt. Click beside the prompt and you can type commands. One of the most useful LLDB commands is print object, abbreviated PO. This command prints a next description of any instance. Try it out by typing on the console. The response to the command is that self is an instance of your controller. Now advance one line of code with the command step. This will initialize the array constant reference. Print the reference value with PO. The response array elements is not very useful, as it does not give you a lot of information. The print command, abbreviated P, can be more verbose. Try it. Another useful LLDB command is expression, abbreviated EXPR. This command allows you to enter Swift code to modify variables. For example, add some data to the array, look at the contents, and continue execution. As you see, you added the object 1. Try to add an object 2 into the array, and look at the contents again. You can also test the command PO to print the array. Perhaps most surprisingly, you can also change the UI with LLDB expressions. Try changing the button's tint color to red. Use continue command to continue your application. As you see, the title of the button turns red. Congratulations! You are closer to a professional developer. See you.